Okay, I was just going to show you really with this feeler gauge, 0.2 millimeters. It just has I can just feel it. It's a very comfortable, accurate fit. So it's a gap, and I actually used the feeler gauge. I put it under here, clamped it, and then soldered the connector, so it maintained the gap. But still didn't work very well. I don't know if you can actually see the gap. Most likely not. It just needed a bit of correction with the dielectric underneath, and I used larger bits of dielectric. Started like this in the corners and around, and in the end I found just needed a little adjustment on this end. Exactly 50 ohms gives a near perfect match. The other thing I did, which I won't show you here now, but I reversed these around, so I put this piece of strip line on the input to the coupler, and I put the loads on the output of the coupler, and just an indication whether the source impedance had changed and whether there was much through line loss. There's hardly any through line loss, and it doesn't make any difference whether it's here or before the coupler or after the coupler. So what is happening now? No power. And this one here, this is the adjustment of the bias. 3 microamps of bias and 1.65 still, and set is still correct. So this 6 dB attenuator is measuring 1.6 VSWR 1.65, 1.65, and that is the correct value. 1.65. Yeah, it's almost a perfect match. That's the 50 ohm load. It's a 20 dB attenuator and 50 ohm termination. So together makes near perfect 50 ohms. Okay, folks. Well, that's probably a messy video, but say cheerio. And let's see what happens. Oh, the camera, by the way, is a car key cam number 16 version 2. It has the narrow lens, the lens A, I think, or is it B? Anyway, it's not the wide angle lens, and it's mounted on the overhead desk lamp, which I can move around. Okay, time to get out of here.